Hello, it's Jason from STEMonline.com, where we are a tutoring company that specializes in advanced mathematics and physics education. Whether you're looking for free advice or you want more specialized help, we help with understanding abstract concepts in both subjects. Okay, so what we're going to look at today is a topic that I haven't covered on this channel at all yet, and it has to do with logical implications. Actually, it's the study of logic in general. Okay. So far on this channel, we've been discussing calculus topics, right? We did that course. We also discussed physics topics, right? Scientific topics. Today, we're going to look at the logical underpinnings of these subjects, okay? Because the reason why I want to look at this subject is because although calculus and physics are good, in my opinion, I find them more interesting than the study of logic. However, though, we cannot deny the fact that logic is very important for both subjects because without a logical underpinning, you cannot be able to solve more advanced problems in either calculus or a physics course. Okay, so we have to look at introductory logic today. All right. Okay, and this course is usually comes up in AP or IB high school courses. Definitely in first year university it comes up again. If either one, if you haven't done AP IB, it'll come up in first year introductory university math. And it's applied in mathematics, philosophy, computer science, economics, and some areas of physics. Okay, so it's very important that we discuss this. Okay, so we're going to look at proving logical implications, specifically the following problem. Okay, that requires truth tables. So how are we going to prove the following? Right, we're going to prove this guy. So prove. Okay, so we're going to prove this. Prove the compound statement that P implies Q. Okay, I'm going to explain what all these variables mean in a moment. And Q implies R. Okay, Q implies R. All these in parentheses implies, right? Should imply that P implies R should be a tautology. Okay, is a tautology. Is a tautology. Okay, so how do we prove this, and what does what mean? First off, I'm going to put down here for our solution section. Okay, so for the solution, I'm going to go very slow and step by step, because that's the best way to teach. Okay. Okay, so what we're going to do is I'm going to list what each variable means. Okay, so first statement P, okay, right, statement P is the first statement. Okay, so P will be my first statement. Okay, P, Q, and R statements. Q is the second statement to the right here. Okay, it's the second statement. R is my third statement. Okay. Okay, so we have three statements. Now, each statement, a statement is something that can either be true or false. Okay, so for P, you have either Either, actually I'll put it over here, I think it's better, be more organized. Either can be true, so either, the either column. Either a statement can either be true or false, right? Same for, that's for statement P, statement Q, true or false. Statement R, true or false. Okay. Now, the point of this is to make a truth table in order to prove that this compound statement is a tautology. Now, what is a tautology? A tautology means that your final statement on the right-hand side, in this case, P implies R, okay, it has to be true. And the only way for P implies R to be true, the whole column has to have all truths. If at least one row in that column is false, then it is not a tautology, and if it's not a tautology, that means that P implies R is not true. Okay, so that's how we're going to go about this. Now, in order to set up the truth table, each statement can either be true or false, as I mentioned. Okay, so, but first off, we need to put every single variable in the truth table. So here's our truth table. Truth table. Truth table is going to be the following, okay? So I'm going to make, let's say we have columns and rows. So let's say we have statement P in one column, statement Q in another column, statement R in another column, okay? R in another column. Okay, so P, Q, and R, okay? Not only do you have to put each statement variable, as I like to call them, P, Q, and R, then I also have to put in the expressions into the table. One is P implies Q. Okay, so P implies Q. Then we have another one. Okay, so the next one is Q implies R. Okay, so Q implies R. Q implies R. Then we have another one which is going to be the whole thing here. Okay, P implies Q and Q implies R. When it's both combined, you have to put the whole expression there as well. P implies Q. And Q implies R. Okay, so you have that. Okay. And we also have to look at this guy here, P implies R. P implies R. Okay, so we have P implies E, Q implies R. And then finally, we have to have the whole expression on the last part here. And the reason why we need the whole expression, this whole thing, is to see if this is a tautology. So P implies Q and Q implies R. So P implies Q and Q implies R. Q implies R. We show that this whole thing implies, okay, right, that it implies that P implies R. Okay, that P implies R. Okay, so what we're going to look at, right, is this. So we have our truth table. Well, we don't have it exactly because we have to determine each statement variable and each statement expression can either be true or false. So how do we decide how many true or falses we have in each column? Okay, well, the way to do that is to look at one statement individually. Okay, as you can see here, that's why I put in my solution area. If you look back up here, statement P, Q, and R can either be true or false. So think of it this way: it can either there's a 50% chance of either being true or false. Okay, since the number of possibilities, in total is 2, because it can either be true or false. Okay, therefore we take a base. Okay, let's take our base 2. Base 2 represents the number of possible scenarios. Either can be true or false, right? There can only be 2 possible scenarios. And since the number of statement variables I have, P, Q, and R is 3, sums up to 3, our exponent n is 3. And the exponent not only represents the exponent, it represents the number of statement variables. So in total, we have to evaluate 2 to the power of 3, which is 8. So we have a total number of true and falses being 8 in each column only for P, Q, and R. Let me show you at the bottom here. So P will have 4 truths and 4 falses. Now, how come, you may be asking, why is it not going from true, false, true, false, true, false, true, false? And the reason for that is because each statement variable can either be true or false. So that means only every 4 truths after rotates to 4 falses and so forth, right? So in other words, what I'm saying is only half of them can be true and the other half can be false. Okay, so that's for P. Then for Q, same thing. True, 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 false, 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 false. Okay, same thing for the other statement variable. Right? R. True, 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 false, 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 false. Okay. Now, we have our statement variable columns with all the true and falses. Now we need to know what the truth table for P implies Q is. If you do not know what it is, please get out your textbook or online reference or online book if you're using, and make sure you remember what the P implies Q truth table is. Okay, not just remember it, make sure you understand why as well. I will also go through the reasoning for why it is. So we look at the first row, true for P, true for Q. So true implying true has to result in true. If you didn't understand that, let me explain why. If statement P is true and statement Q is true, then the operator implying, right, the operator in this case is the implied sign, then if it's true implies true, it has to be true. Okay? You can't refute that. This is a fact, okay? Next row, true implies true is true. True implies true, we already know is true. True implies true is true. Now let's see what happens for the next four when we have all four falses. False implying false. Want to take a guess? If you guessed false, you're incorrect. It's true. Okay? All right? False implying false, right? Automatically has to be true. Think about it, right? Let's go to the side here, or maybe I'll go on the bottom. Let's go to the bottom. False implying false, okay? Remember, if you remember your formulas, your logical symbolic formulas, that if you have P implying Q, this can be written as an OR statement by saying negation of P or Q. Okay? Write it this way. So, if we have negation of P or Q is equivalent to P implies Q, where P is false and Q is false. Therefore, replacing P and Q with false, I get negation of false or false. Negation of false has to be true, right? So true or false, and we know that true or false is equivalent to saying true, because true or false automatically logically implies that we have it being true. You can either have something to be true or false. Okay? So that's why false implies false is true. Next, false implies false is true, false implies false is true, false implies false is true. So we now know what P implies Q is. Let's look at Q implies R. Now for Q implies R, we're focusing only on Q, column Q and column R, so be careful. So now we look at true implies true, true, true implies true, true, true implies true, true, true implies true, true. Then we have false implying false, if you remember, because I disproved it down here. If you had trouble figuring out why false implies false, it's true. True. False implies false. True. False implies false. True. False implies false. True. So again, not only do we have P implies Q being true, Q implies R is true. Okay, so since we know what P implies Q is and Q implies R is, that's why I made the next column, which states that P implies Q and Q implies R, what it has to be as well, okay? So looking at P implies Q, is true, and the AND operator, Q implies R, is true. So that's saying true and true. What does true and a true imply? It has to be true. Make sure you understand the AND operator, okay? So the AND operator, I'm talking about the truth table for AND. P and Q, what the truth table should be. And even if you don't know the truth table, you can figure out very easily that true and true has to be true. Again, next one, true and true is true. 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 Okay, again, we're having all truths in each of our columns. This is good. Now let's look at P implies R. We're going to focus on this guy and this guy. If you're getting confused between the columns, that's not a problem. You automatically know, without even thinking, that P implies R has to be all true. And the reason for that is because P, Q, and R had all truths in each column. Okay, so that means that each row will be true, 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 4 truths, and 4 truths again. True, 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 true. Okay. Okay, so we know what P implies Q is. We know what Q implies R is. We know what P implies Q and Q imply R is. Okay. And we know that P implies R is true. So we want to figure out what the question was asking. Prove that P implies Q and Q implies R implies that P implies R is a tautology. Okay? Well, that's very simple. On the left-hand side here, for the first row of P implies Q and Q implies R, we knew it was true. And Q implies R was also true. So true for this guy on the left-hand side, true implies true is true. And guess what? All the rest of the rows are all truths as well. So we don't have to go step by step. You know, this is all true. True, 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 true. And we're done. And the reason we're done is because we've shown that the final column that P implies Q and Q implies R implies P implies R is a tautology is because all rows in the final column for this specific statement are all true. And since they're all true, we have shown, right? This implies, right, that the following statement that P implies Q, right? P implies Q, and Q implies R, right? All this, which implies that P implies R is a tautology, right? Okay, so we've shown that this whole thing is a tautology because the final column is filled with all truths. Is a tautology. Is a tautology. So it's been proven. And that is how we prove logical implication statements. Okay, so if you like this video, don't forget to like and subscribe. There will be more videos coming up. I'm going to make more YouTube videos more often. I've just been busy with other projects, but yes, there'll be more videos, especially on logical implications, logical inferences, proofs, different ways of proving an argument, standard proof methods, because it's very important to understand how mathematical thinking works as opposed to just knowing the formulas, like in calculus. Okay. Hope to see you next time, and have a great day. Bye bye.